Okay, so our team has the idea of making this linear production system, which we wanted to have the three more important exercises we did across the course. One of them was a velocity control for DC motors. The other one was the gripper, like the Lynx robot, and the other one is the vision system. So we wanted to think this project as a production system in a company or in a factory, and we built this by each one of us doing a part of the system and then just getting it together. Yeah.
Okay. Do you mind introducing yourselves?
Yeah. Well.
Just say who you are.
Oh, we are Team 3. He's Rodrigo, Claudia, and Arnoldo. So the first part here is the DC motor system, which Claudia is going to explain.
Yeah, I want to try to do the implementation of PID control, but there was a problem because I learned how to do it in MATLAB, and I want to pass the code to the Arduino, but I can't to the controller isn't functioning. It's not really good. It's like only receive the signal, but I can do all that I need to do because in MATLAB I have Simulink and other tools that I can use, but in Arduino for me it's more difficult. But I try to do all the things I want to do, and we use a sensor that it counts the RPM. It's like this, and I want to show it. It's a kind of encoder that it counts how many the engine is working. But like I say, I try to to connect LabVIEW with other Arduino, but I can't. And the other part was the motor control and the gripper. Is going to explain Rodrigo.
Thank you. For the next part, I built all the structure. So first, the DC motor just had to move the platform backward and toward the linear actuator and the gripper. The problems I had here is that the guideline was, even if I can reduce the friction losses and the mechanical loss of the system, the guidelines were like not stable enough, so I had to fix them with some I don't know how to say it. Well, with some structures, and well, that's it for the DC motor. Now for the linear actuator, it actually worked well with a H-bridge system fitting by the Arduino, and the only problem I had, it was like really quick to solve, that it requires like a ton of currents. So in some tests I realized that the linear actuator absorbs like from 200 million amperes to almost 3 amperes. So it was like really important to get an external source voltage supply to avoid damaging the Arduino and the computer. Finally, for the servo motor, I acquired this gripper, and I adjust them to keep the movement and select grab the pieces. It had like two servos. I don't know if you can see them from that angle, but it had one here and the other one in the closed structure. The original idea we had was to have a vision system that my partner Arnoldo will explain in a moment, but for the physical structure we had to keep moving the piece, and if it detected it was like some color or some mark, it would keep the process going to the linear actuator when it will like print some paper on it and says it's okay for production, and if it was incorrect, the gripper would remove it for the line of production. And now I'll leave you to my partner Lolo.
Okay, so the vision system, we wanted to implement this system by being not dependent on what we have. Why? Because sometimes if the system has a problem, it just creates more problems inside the system, and we don't realize. So the camera is completely different from the system, from the main system, and it was kind of difficult at the beginning because we started identifying colors by the red, green, blue color chart, and it was very unstable. So we did some research and find out that HSB color model was a lot more better to what we were looking for. So here we can see the original image of the camera right now, and then the HSB transformation. This program have the main goal of identifying color, in this case yellow. So this is the binarization, and if I show this one, we can see the yellow, the white circle here. And it doesn't matter if I just show it in the middle, it's just very good. It doesn't matter if it's close or is it far away. If we have a very good range of color, it will work. So in this case, the camera is going to be looking to the system by this side, and by setting this, we can see the position across the platform. And at this point of the project, we have the linear position by the DC motor, the object recognition here, and the actuators here and here. So, this was the project, and we did have some troubles. For example, we couldn't make the communication between the camera, the program, and the Arduino. It was by serial communication, but I don't know why we couldn't. And part of this is that depending on the object recognition, it will activate this actuator or that one. I think we can already show one of the sequence. ¿Esta qué secuencia es? ¿Esta qué secuencia es? ¿Esta qué secuencia es? Ah, pero no va a llegar la revista. Okay, so we can see that the movement here is kind of slow, basically because of the voltage we're given here, and we can get more voltage because this one is getting all the energy for all the system. So just something important here. Here we can see that this might be an actuator that can label or that can penetrate or whatever. In this case, it just make a move to represent an action here. And then we can see that it will go to this side. Another part of here is the construction of all the structure was something very different for us, because I think we are used to just doing the robotics part and not the main base of everything. So it was something that well, in my opinion, I never did before, and I think I learned a lot of this project.
Well, as Arnaldo was explaining, the voltage source we could not level up the voltage supply because specifically the servos just tolerate until 7 or 6 volts. 6 volts, sorry. So if we get like a faster system, we would be absorbing like a lot of current and it would burn the servo motor. And that's it for the structure. We had some troubles, like my partner already said, coupling the vision system and the Arduino, but the original idea was to detect that the piece was like approved for continuing the production, or it was a damage and it had to be removed from the line of production. And what I learned from this instructor was to well, basically all the physical problems we had to solve in order to make the system work, because it's not like the same like just go and buy something commercial than going step by step and designing the whole structure and having some troubles, as we have seen with the guides and with the servo coupling. Even if it's commercial, it had to be some modifications in order to accomplish the goal we were looking for. The Arduino was like very easy to program, but we still have like a lot of tests, and maybe in a next stage of the development of the project, we'll have to change these structures in order to have to avoid this glue stuff and make it completely mechanical and keep the movement of the infinite screw going. Also, we have to add some safety structures, and if we have to, well, obviously this prototype would not be like an industry, but in a real product we have to add some security stuff like a switch and a break-in for emergency in order to avoid some damage if the structure did not detect or have some trouble, or even if the gripper go too much down or the piece was too big. We have to get that considerations and maybe check some regulations, and of course make the structure from metal and go directly with a supplier that could make all the structure.
Okay, so do you want to say anything else about this, or do you want to tell me what you learned? What did you learn with this project?
Like my classmates said that we try to integrate all the things that we learn in the class, like in all of 3 partials. That it's we learn a few of mechanicals how to do it. It's like we don't learn in the class how to do, but we have only to imagine, because we didn't go to a real project. That I know that for industrial project we don't use like this implementation, but we have to use PLCs, for example, PLC, and it's for industrial. But we try to do to a final project. No, it's like we try to divide the activities in order to get a good project, like in only one thing. Only it's like 3 things in one project. We have to think what is final project to implement all the things that we learn. And I believe we learn not only in this project, but in all the class. We learn a lot of equations, like how to do the movements, and motors too, kinds of motor, DC motor, step motors, and how to differentiate, what is the best for one job or for the other job, and I believe we have other view now to the things, to the robots, like it's a vision more expanded like in the start of the semester.
I would just like to add that I think this kind of project that you give the freedom of choosing what to do is something that we really take advantage of, because we did the system based on the three principal things we saw in class. But for example, in the control vision system, in class I learned about the border detection, edge detection, but it was the base for what I did, because I was reading and I found out about the HSV model, about other types of color models, but not only that, I mean about recognition, object tracking detection, and many things which I might not apply here, but I know, like the source detection by features detection, and I think it's the goal of this kind of projects, like not only doing what you are planning to do, but researching and going deeper, and you find out that you have a lot of things to learn, and they're very, very interesting, but you know the base, so you might understand. So I think that's great.
Well, finally, as Claudio said, we realized that the components were maybe for educative purposes, and on the industry we will not use like an Arduino or these kind of servos, but knowing how to control them in a small scale teaches the principles that will apply on a bigger systems. Maybe, as Ronaldo already said, one of our mistakes was to go and plan the project without do some research first, and after we did the paper review, we had some ideas and a general view to get what's going on and what's been doing on the CNC systems, such as vision system recognition, or considering the effector, or in this case a gripper, as a sub-kinematic chain, and not just stopping doing this, if not developing the project and see some opportunity areas to get better at the prototype, and maybe doing some, not commercial, but give something to the researchers to work with. For example, when I was reading all the papers, I realized that they go on vision system completely, or they go with some sensors such as accelerometers and stuff. But then I think, why can they combine them and get some data comparison, and then okay, we will like use the vision system for recognizing damages or some colors or whatever, and the accelerometers to get the efficiency of the system. The platform that we had some problems first, that it was like unstable, maybe with that, and for the feedback from the DC motor, we could use that what Claudia used, develop the code, or we could use some ultrasonic sensors, or maybe some more professional option. But the idea is to get some proximity data that could locate the piece and detect even if it's bigger or if it is like small, or if moreover that the system could work with it and adapt the system, not just getting like, oh, I did this, it works for, like, for example, like this piece and just these pieces. No, getting an intelligent system that could react in real time and really generate some tools that could help developing, for example, I don't know, long production of processes or whatever kind of devices, maybe to assemble them or assemble some structure with this kind of technology, or the general idea.
Very good.